All right. Thank you, everyone, for coming to our second session of the Funky Morph Users Group. So sorry about the delay in getting the link out to you all. There's some Gmail issues today. For future reference, know that we put the Zoom link in the collaborative group notes, which Jonathan has linked in the chat ahead of time. So if there's like an issue in the future, look there. But we will make sure we get that link sent out earlier in like days before in the future so that we don't run into this issue anymore. So be patient with us as we're getting this nicely polished, well-oiled machine together. So we have our collaborative group notes, as we mentioned, so feel free to enter questions in the group notes there. But overall, we encourage you to put questions into the chat feature. Jonathan and I will be monitoring those questions, and we'll bring those up to Eva as she's going along to get those answered as we go. I want to remind everyone that everything in the shared Google Drive folder link that we sent out is considered private. So this is only for folks like yourselves who have read the code of conduct and registered for this group itself. We don't want that material out shared with just anybody or used in any such way. There's some unpublished data and things like that. So anything on our GitHub page is open source. It's general announcements, other links to things that are widely shareable. So just please keep that in mind, the distinction between the two as per our code of conduct. We also have a Slack page. If you have not received a Slack invitation, you can maybe message one of us in the chat or send us an email after the session, and we'll make sure you get invited to join the Slack page. I think that is all I have. I'm going to turn things over to Sandy. I'll quickly have Zach and Jonathan, and Sandy and I will all wave. We are the organizers of Funky Mug of the Mid-Atlantic region, so feel free to direct message any of us at any time as well. All right, take it away, Sandy.
Well, thank you very much, Emily, for the wonderful introduction. It is my absolute honor and delight to be welcoming and introducing our invited speaker, Dr. Eva Herbst. She has been working on a number of really fascinating topics, starting off from when she was an undergraduate. And she is currently a postdoctoral researcher at the Paleontological Institute and Museum through the University of Zurich. So it is very late for her, and I thank her for tuning in late. Currently, she's working on 3D biomechanical modeling that includes finite element analysis to understand the functional morphology of Triassic reptiles. But she has also been working on the water to land transition in vertebrate evolution, where she combined both living as well as so in vivo and ex vivo techniques to look at musculoskeletal modeling in salamanders, and really found some fascinating work on this really obscure fossil Crassigyrinus, which is the STL file that she has shared with us. This thing is really crazy. What is it called? The tadpole from hell or something like that?
So we gave it that nickname because it's basically like the bone we'll be working on is the ulna, and it's about this big. So only a few centimeters, and the forelimbs were tiny, but this animal is really, really big with these tiny forelimbs, and then it has these big fangs. So it the body shape kind of looks like a tadpole, but then it's fanged. So we always referred to it as the tadpole from hell, and it's just this really bizarre animal.
Yeah, and so she has been finding some really interesting pathologies within that animal, finding some new bones that previously weren't found through her investigations of the fossils. So this is really, really exciting, and she's also been really involved with open science. She is one of the ambassadors of the Open Life Science program, where she has been working towards making analyses and biomechanics and functional morphology more accessible to others. And she is even, with her busy schedule, also helping to coordinate and lead a seminar series and a workshop on finite element analysis that's happening later this week. And I believe today is the last day to sign up for the seminar, right?
Yeah, well, tomorrow is also possible. We're just going to keep it open till the end, but I think tomorrow we'll send out some general information emails. So I can actually, I'll put it in the chat I'll put the website in the chat if people want to sign up for that. So this seminar series is basically intended to cover like a wide range of researchers that are all using finite element analysis, which is essentially this biomechanical modeling method where you have a model and you divide it up into a discrete number of elements, and then you can see, and you assign it different properties. So for example, if we're looking at skeletons, we assign it the material properties of bone, and then you can apply a force such as joint contact forces or muscle forces, and then you see how basically the model is like a physics simulation, so you can calculate how the stresses and strain distribute throughout the model, and then you can also see like output forces like bite forces or other joint contact forces. And the lecture series is really intended to showcase like all the different labs that are using it, or some of the different labs that are using it. And we also want to start forming this community. So we have like a GitHub repository and a website, and we want to just encourage people to share workflows, because one of the issues is that a lot of the software that's used both for preparing the meshes and running the analyses is commercial, and it's really expensive. And so you get different labs using different software. And if you don't have access to that software, if you don't know someone else using that software, it's really hard to learn. And that's kind of where this Blender stuff came in for me too, because we were using Aviso, but there was like a time when we didn't have an Aviso license, and we were using Blender anyway, but for if we had like fossil skulls where all the bones were scattered, we were using Blender to reassemble them. And then I realized it's really dumb to have a workflow where like someone in my lab segmented it in Mimics, and then I put it in Blender, but then I have to put it in Aviso to remesh it and clean the mesh, and then I put it back into Blender to check it, and then I do my FEA and my other programs. So I basically wanted to figure out like, how do I make this mesh cleaning step all in Blender, because Blender is free, so it's like available to everyone. If I switch labs, I can still access it. And then like more people can also share these methods. So that's kind of the motivation behind me learning all of these steps in Blender instead of, for example, Hypermesh, which is one of the programs that you, or Aviso, which are one of the programs that you could use to prepare your meshes. So for finite element analysis, it's super important to have really clean meshes. But also if you want to 3D print something, or sometimes for range of motion analyses, like a lot of the tools that I'll teach you today are not just specific for finite element analysis. They're also just useful for making a clean mesh in general.
Well, awesome. I'm very excited. So go ahead and take.
Cool. So if everyone can open Blender and just open a new scene, which should probably automatically open up, or you can just go File and New. And then you'll see that there's always this cube that comes up, and it's an actual object. So to select things, you just left click and select it. And here we don't really need the cube. I think it's just there for like a scaling reference, but we can just press delete and get rid of it. And then we'll go import our model. So we go to File, Import. And so I shared the Crassigyrinus ulna with everyone, but also if you have a mesh that you want to practice these things on, feel free to upload your own mesh. We can hear all the different formats you can load into Blender. So it's really up to you what you want to work with. And I'm happy to later, if you have any questions about your specific mesh, I'm happy to go through those as well. So we have our ulna here. Is everyone so far, and as I mentioned earlier, I have everyone's videos on the left side, so that's why I keep looking to the left, but is everyone able to do that and load the model? Yeah, okay, cool. So then I'll just show you some really basic Blender like manipulation and transformation things. So these are not always necessary for your meshes, but I think it's just good to know them, because otherwise it takes a really long time to figure out how to navigate everything. So first of all is the move tool, which is really useful. And basically, sometimes you might import a model from a CT scan. Maybe it'll be like all the way over here, but you want it in the center, or you're assembling various bones. And this tool is just really straightforward. You can move the model around with it. So you can see that it's centered right here. And sometimes if you import a model, you can pick where you want your center of rotation and center for the movement to be. So to do that, you want to change it from the default. I don't know, say we have it over here. Sometimes you want to have it in the center of the object. Sometimes you want to have it in the center of the scene. So you can right click and go to set origin. And then if you do origin to geometry, it will center it on the geometry of your object. But if you go to set origin, origin to 3D cursor, it goes here in the middle. So then sometimes that's useful because the axes you can see line up with the global axes, and sometimes your object will have axes that are like skewed from the global ones. So the global means like the scene in general. So this is the 3D cursor, but say you want to move the 3D cursor and you want to say, actually, I don't know, I'm looking at like a joint in a limb and I actually would like to have my center of movement and rotation up here. You click on the 3D cursor over here, and then you can place it wherever you want. So for example, I put it here, and then again, we can go to set origin, origin to 3D cursor. And now you can see all the movement is actually up here, which is especially useful if you're rotating something and you want to rotate it not about the center of mass of the object, which is when you set it to the geometry, I think it's either using center of mass or the center of the bounding box, but maybe you want to have it at a specific point. So those are all things you can do to manipulate your object. And then you can go say, I want it back to where, want to put the 3D cursor back to where it was. So we click back on the 3D cursor and then we go Shift C, and then it goes back to the center. So I'm just going to move my ulna back roughly in the center. And then I think I'm going to go over next, like how to change the angle you're viewing the model. So to rotate, you use your middle mouse button. And then you can also decide if you want it in perspective view or not. So up here to the right, there's this view image, and you can see like this is like a perspective, it's a symbol of a grid, and it's the perspective. So you can change it from one to the other, whichever is more useful for you. And another useful thing is you can do click Alt and middle mouse button, and that will basically give you like all the different views that are lined up with the global plane. So basically having like two axes in your view and then the other one like coming at you. So if you hold Alt, middle mouse button, and then like drag with your cursor around, you can see like how this would be useful, because then you can really easily view it from different things without spinning it around. I think at this point, I'm going to ask, does anyone have any questions? Is there anything that didn't work for anyone, or is that all good to go? Yeah, okay.
Sorry, can you just repeat that last amount, key click?
Yes, so it's holding down the Alt button and then middle mouse, and then you have to drag the middle mouse across the screen. So you have to just basically move the cursor. So imagine like the dragging is telling it which direction. So if you drag up, it'll spin it that way. If you drag down, it'll spin it the other way, and then side to side.
Okay, thank you.
Mm-hmm. Any other questions? Okay, cool. So now
We have one more question. Sorry, Eva. Felix?
Yes, yeah.
Sorry, I seem too old and stupid to download from Google Drive. I clicked right-click download and it doesn't come up. Is it? Sorry for my old school brain. Normally it should download then, or?
Is this for the model? Oh, I think you're muted.
Oh, sorry. For the model, yes. I opened the Google Drive in Firefox, so I had access to it, and I clicked right-click download, and nothing. Is it somewhere in my Google Drive now? Because Google is crazy with downloading, and you don't need your own hard drives anymore in their minds, or is it just me being stupid? I don't know.
I'm not sure about that. I haven't tried the download, but I'm guessing it worked for other people. I don't know.
Yeah, it might have been that, so Felix, it might be possible that the file defaulted to a very specific folder for Firefox. So if Firefox has its own download folder, it could be in there.
No, no, the download just didn't happen, but I'm looking still through it. I just wanted to know if there was some standards I didn't know, because I'm used to download files just on a click, and might be that Google Drive is some stupid stuff, but sorry for my language.
Maybe we can
Totally
email
fine.
it to you.
But just go on. I will grab everything what I need. So
Okay,
I was
or
just
if you want, I
asking and
think-
wondering.
There's an option to upload the file, so we can go ahead and look for the STL is 2 megabytes, so it's not very large. So we can upload the file directly to the chat box. Just give us a few minutes.
Okay, perfect. And then yeah, I'll just continue meanwhile.
Mhm.
So one of the other things that you want to do in general when you're working with this, especially for the mesh cleaning, this is important, is they're like these viewport overlay options. So they're like kind of 2 circles, like a Venn diagram almost. And then you want to activate statistics. So you can see already here, it'll tell you how many. Oh, and by the way, sometimes this menu that's up here at the top for me will show up at the bottom instead, I think, depending on like the Blender version and the settings. So if you can't find it up in the right-hand corner, it should be up in the, well, bottom right-hand corner. And that's really useful because it already tells us, okay, we have one object, these are the number of vertices, faces, triangles, etc. And you can see if you zoom in, you can kind of see the faces, but you don't really see the edges. So if you want to be able to see the edges in object mode, so right now we should be in object mode, which you can pick up here. Then you can go to this orange object properties button, and you go to viewport display, and then you click wireframe. And here we can already see what our mesh looks like. So depending on your preference, I mean, we do all the mesh editing in the edit mode anyway, where we can see the all of the edges and things like that. But I just wanted to let you know that there is a way of also seeing in object mode, which is helpful if you have several meshes, you want to see the wireframe of all of them. You can turn it on and off as you want. So then to go between object and edit mode, it's up here, this drop-down menu, and you can also just do tab to switch between them. So here you can see then it'll show you your, right now it's highlighting the vertices. So up here, there are 3 different options. So vertex select, you can do edges, and you can do faces, which is really useful because for the mesh manipulations, you'll want all 3 of those. But before we dive into the actual mesh manipulations, I want you all to install an add-on, which is really easy because it's like already packaged with Blender, but it'll help us for some of the steps. So you go to Blender and then edit preferences. Oh, and that's not letting me, well, I think it's not sharing this window, but it's pretty straightforward. So I'm just gonna, because I think it's just sharing the Blender window, and this is like a pop-up window, but it's pretty straightforward. So we can just go through that. So Blender, edit, preferences, add-ons. And then in the search bar, you just type 3D print. Or print. Just type print and find it, because there's no space between the 3D and print. So just the easiest way to find it is print. And then you just make sure that it's checked. And then to make sure that it's actually showing up, you can close that. I'm actually wondering, you might have to click install because I already have it installed, so I'm not sure. But to check that it's there, you go back into your Blender screen, and then there's this tiny little arrow on the side, and then it should show up as a 3D print, like as a separate tab that says 3D print. Was everyone able to do that? Yeah? Okay, cool. So we'll use that a bit later on, but that's just a useful thing to have for the mesh editing.
Can I
Yes.
I'm sorry, I don't have the hand raise button on this Zoom for some
no
reason.
worries.
I'm Jenny. Can you go through one more time where you just checked that you had that? I think we did it, but I didn't see.
Yeah. So there's you see this box popped up, and basically before it's popped up, there's like just like a tiny little arrow that's next to your, there should be like a hierarchy of the scene that lists your objects. And then next to it, there's like a tiny little button. And if you press it like a little arrow, it like expands. And then you can see there's like item, transforms, tool, view, and then there should be 3D print. Do you see it? Okay, perfect. All right. Let me check.
Sorry. Can you show how to access that 3D print thing again? Because I missed that bit.
Yes. Yeah. Okay, so you go to
thank
edit.
you. Sorry.
Yeah, no
I'll
worries.
edit. Okay, thanks.
Preferences, and then add-ons, and then just type in print in the little search bar, and then you can find it there.
And is it called Mesh 3D Print Toolbox?
Yes, exactly.
Okay, thank you.
Yeah. All right, let me see. I've done that. Okay, so I'll go over some really general mesh stuff first, like how to even just select things, etc., and then we'll go into the actual cleaning. So as I mentioned, there's the vertex mode, edge mode, and face mode. And when you're selecting something, it'll always select it based on that mode. And there are also different selection modes. So you can like have a selection box, you can have a circle, and you can have like a freeform lasso tool, which I find to be the most useful one. And you can switch between them by clicking W. So you can see like it's going through the different ones. So I'm just going to do a select box. And then, so right now, for example, I have it set to face mode. I could just select whatever shape I want. And another useful thing is you can press H to just hide those. So then you can see inside your model that way. So they're not deleted, they're just hidden. So that's a useful feature when you're looking at all of the mesh components. So then, okay, let's see. So we'll go through like a bunch of different problems that your mesh could have, and then how to find them, and then how to fix them. But first I want to go over some terminology. So basically we want our meshes to be manifold, and that means essentially that they can like exist in real life and also be like you could cut it on one side or on several sides and at some point lay it flat. So it means that there are no like unreal geometries. So examples of that would be you could have a face that has 0 area or an edge that has 0 length. So in the program, those things still exist, but they're actually not physically real. Or you can have T-junctions. So you would have like an issue here where you would have, for example, something like this. So you have like this connection just doesn't connect to any other vertices here, whereas really you should have another, it should really look like this.
Ava, we have a question from Pauline. Go ahead, Pauline.
Thanks. How can you deactivate the hidden areas?
Oh, yes, good point. So say I have it hidden, and then you go to Alt-H.
Thank you.
Yeah, that's a really good point. Right, so other issues with the mesh could be holes. For example, I put one here. So basically it's not watertight, and that's something that's also really important for if you want to 3D print something, you need a watertight mesh. Also for things like if you want to calculate, like here in the 3D print add-on, you have the volume and the area. If you want to make sure, or like if you're writing code to calculate some of these things, you want to make sure it's watertight. And sometimes the tools just won't work if it's not watertight, but sometimes they will work, but they'll be wrong. So just make sure that whenever you're using some sort of calculation tool, the mesh is correct and watertight, or you know for sure that it doesn't matter whether it is, but for most of these, it should matter. Another thing that I'm going to mention really quick that I didn't mention before, and it's kind of unrelated, but it just crossed my mind now, is that I'm going to go back into object mode really quickly, is that if you have some sort of transformation, like for example, so this button here is changing the scale. So say I make this ulna smaller for whatever reason, maybe you forgot to put your units in when you did your CT segmentation or whatever. If you scale it, you can see now that in this object properties again, the scale is now not 1, it's 0.35 because that's how much I scaled it down. But again, sometimes depending on, like usually in my experience, when I export things, it's fine. It'll export it like as it is in the scene. But sometimes for other things, like when I was writing code for a volume calculation or something like that, it won't have applied that scale. So it's still calculating like what it would be if it was at scale 1. Same with rotations. Maybe you like move so this is the rotation tool. Maybe you move this ulna around, but you actually, and so we have all of these rotations, but maybe you want that to be your reference pose and you want all of your, maybe you're doing an animation or something or some sort of range of motion analysis and you want all of your angles throughout the scenes to be relative to that null pose. So ideally you want to tell Blender, actually, I want this position, like when it's in this position, it's 0, 0, 0 for all the rotations. So basically these things are called applying transformation. So basically telling Blender, this is the reference null pose, 0 rotations, scale 1, etc. To do that, you do Control A, and then you can apply location, rotation, scale, or all transforms. So again, not super like related to mesh cleaning, but this is just something that I didn't know about. And then I was trying to calculate the volume and I was like, why is it suddenly different than it was before? So I think it's just an important thing to mention. And undo all of these. Okay, so now we'll get to the actual mesh cleaning. So Blender has a lot of built-in checks for the meshes. So what you can do is you can do select all by trait, none manifold. So these are all of the different things that I was telling you about earlier. And you can also do it for both in vertex mode and in edge mode. So in vertex mode, it'll tell you which vertices are problematic. In edge mode, it tells you which edges are problematic. So you want to do both. So you go select all and make sure nothing is selected beforehand. So to do that also, if you had something selected, you can just click like somewhere outside of the object and it'll just unselect, or you can go select none. So then we go select all by trait, none manifold, and here we can see there's a hole here, so it doesn't like that. So the way we fix this hole is, first of all, if you had more, and it tells us, okay, there are only 3 vertices that are the problem. So we can see, okay, these are the 3 that are the issue. If it said, whatever, 10 vertices, 50 vertices, whatever, then when we're correcting this hole, then we want to make sure that we're actually only selecting these certain ones. So you might have to manually select them again because you don't, whatever operations you're doing, or if you're moving something or filling a hole, you don't want to accidentally be applying them to all of the other vertices that Blender selected to be an issue. So I think we have maybe some questions.
Yeah, so Ava, Pauline's asking, I don't have the option non-manifold.
Okay, are you in edit mode?
Yes.
Okay, and are you in vertex mode?
Oh no, maybe that's the problem.
Yeah, so face mode doesn't have that, which is
yep, it's there. I missed that point.
Yeah, so I talked about like the 0 area faces also being an issue. So for fixing the faces and checking them, that's when we use the 3D print add-on. So the way to fix this, well, the way I usually do it, because I like being able to like zoom in on the problem areas and exactly see how I want to fix them. So I usually do it like kind of manually. So you can select all of the vertices on the corners of the hole, or since this is the only problematic area, already will have selected these for you. And then to select several things, you hold Shift when you select them. If you accidentally select something you didn't want to select, then you can go Control and then select it again and it'll remove it from your selection. And then you press F and it just fills the hole for you. Okay, so another way to do this is there's also mesh cleanup. and you can fill holes. So it'll fill any holes in your mesh, which is like the quicker way to do it. I personally like to be able to see all the problem areas to see, okay, why did this happen? Or maybe if you have a really big problem area, like say there are all these areas and I'm just gonna delete all the vertices here. Then we can go clean up, fill holes, and it actually didn't work. So I prefer to just go in through the selecting the non-manifold issues and then just go piece by piece until there are 0 issues left and actually fix it myself instead of any of the automatic fixes. The 3D print add-on also has checks and it has a cleanup option that just says make a manifold. So it'll just do it all for you. And again, that can be really useful, but depending on what you're doing, and I think especially for finite element analysis where the shape of the triangles also matters, I prefer to go in personally and look at each one instead of just selecting them all and cleaning them all and not really knowing how the morphology is changing, if it's changing. So those are some ways to clean up the holes. Let me see what I have next on my list. Let's see. Sorry, I'm just trying to make sure that we have everything covered. Okay, so yeah, let's talk about 0 edge and 0 face length. So this is where the 3D print add-on becomes really useful. And these 0 area faces and 0 length edges are referred to as degenerate geometry. So you can even see it here in the description of the 3D print add-on. And here you can run a check through the 3D print add-on, and there's also the threshold. So this is quite useful because we can not only say we can check for 0 area faces, but we could also say, okay, we have a finite element model that generally has a certain size of face. And we actually want to make sure that there aren't like some really tiny triangles with very low area in there as well. So we can put the threshold, like we can change the threshold and see and make this add-on select whatever is under that threshold. For example, we can click on degenerate and you can see 0 edges have this problem, loads of faces have this problem. That's under this result here. And then once you click on the thing, so you can click 0 faces, and then it should be showing you these issues. And sometimes it's a bit hard to see, but you can see right here, we have this really, really thin face. So what's happening is that there's a face here, but it looks like an edge because the 2 edges are so close together. Just saw someone else put something in the chat. How do I pan or move the object in 3D space without rotating? Oh, right. Okay, perfect. Yeah, so you mean like instead of rotating the object, but just changing the view, you go, you go middle mouse button and then you can move it around. Does that answer your question?
There's another question in the group notes, Eva. Is there a limited number of times you can undo, like in Aviso? Also, what's the shortcut for undo?
It's Control-Z, and I think you can maybe set the memory limit for undos, but I'm not entirely sure. But I haven't had the issue of not being able to undo anymore. So it's generally pretty good. This is also why MeshLab can be useful, but I find it like really frustrating if I've cleaned meshes in there and it's a massive pain because you can't undo. Also for the navigation, if you do Control, you can zoom in and out if you move your mouse left and right. And then you can, yeah, these are back to the Alt things. And then Shift middle mouse button is translating the view. So you're not moving, for all of these, you're not moving the object, but you're just moving the view. Sorry, I should have gone over that before. Alrighty, so the way to clean up these really small, so the way to clean up the 0 area faces and edges is you can go mesh cleanup and then degenerate dissolve. And then in the bottom left-hand corner, there's this little bar that says degenerate dissolve. And again, here you can also put in a threshold, and then that'll, so this is just, I think, for the 0 area ones, because that's the non-3D print add-on thing. And then you can tell it to merge within a certain distance. So if you have 2 edges or 2 vertices that are really close together, they'll just become one. So I'm just gonna, this is easier for me to just do it manually, but like show you what this tool would be doing. So for example, if these 2 vertices were within that threshold, then it would basically do this. It just turns it into like a single edge and a single vertex instead of what it was before. Also, this might be a good time for me to tell you how, if you wanted to do it manually, this is how you would do it. So there's something called the snapping tool up here, which is a magnet symbol, and you can tell it what you want it to snap to. So here I said vertex. And then I also have this opted here. So right now I put them on top of each other, but they're still 2 different vertices, whereas here you can say auto merge, and then you can also put a threshold. So this is more oriented towards if you're personally like adjusting things and creating your own faces and things like that. Like say there's a hole you're patching and you drew some edges in there and actually you realize, oh, I actually drew these edges way too close, but I want to make sure that they turn into one edge. This is what you can do. So yeah, to review again, snapping tool, pick snap to vertex. Up here, options, auto merge, you can put the threshold, it'll depend on your model, you can play around with it, and then move it. And then to make sure that worked, we can go through the checks again. Then there's also the 3D print cleanup, but again, that's just like in general, it makes everything manifold. So it's very quick and useful, but personally, maybe I'm too mistrusting, but I like to see where the issues are and then how to fix them. All right, let's see. So we went through holes, faces, this. Okay. I'm also going to go through, so we had a really easy example of filling a hole. I'm going to go through, for example, if you have a really big region that's a hole and you need to basically fill that and make the triangles yourself. So this wouldn't happen that often, but there might be a few cases where you're actually making your own geometry. So for example, this happened to me when I was trying to model teeth in a fossil jaw, and I was doing a sensitivity analysis checking, does it matter whether we model the teeth as all bone, as some people do, because then you don't have to segment them, and bone and dentine material properties are similar, and most of the tooth would be dentine in these species that I was looking at. So reptiles, for example, in general, they have more dentine than enamel in their tooth, but there's still like a thin layer of enamel. So I wanted to model the thin layer of enamel, but then in like using a viso, basically the issue was like the layer was so thin that I had like a pixel layer, but then the resolution of the mesh was so big that I couldn't do anything with it. And then once I downsampled, like the different layers of the tooth were just intersecting each other. So they'd be like the dentine layer and the enamel layer would be like cutting through each other. And what I ended up doing is I used the tooth from the CT scan, I used the tooth shapes, but then I made, and the measurements, but then I like remade the tooth meshes in Blender to make them clean. And so that's where I learned a lot of this mesh manipulation stuff. And then I needed to like merge, basically suture them to the teeth to the jaw of the CT scan where I just used the normal scan. So that's like just one example where you might have some areas that you're stitching together and where you actually have to maybe draw in your own faces. And I also wanted them to be like pretty evenly spaced and things like that. So I can show you how to do that if you ever have to, adjust areas of the geometry that's not like just one missing face, but like a bigger region where there's a gap. So just gonna select a region and delete it. And also when you delete, you can delete, if you really want to delete the whole area, just delete vertices, but you can also have these other options. So you can only delete edges or faces. And the dissolve functions will, so the surface will still be there, but like the edges will disappear. So that's, for example, what the dissolve looks like. Whereas here, I'm just going to delete the vertices. We have this big hole. Now, what's really useful, and so I say I want to select this boundary. What's really useful is instead of selecting each vertex 101, you can do this in the edge mode or the vertex mode. You can actually do, okay, the geometry is kind of messy, so it doesn't like this as much. Yeah, so sometimes you have to like double click on it for it to work, but if you press down Alt, so I have one select, I press down Alt, and then I left click one of the vertices on the boundary, and then I double click it. And then you can see it's selecting the entire perimeter, which is super useful because then you don't have to go in and fill up all those gaps. Or sorry, and select all those vertices. So then to fill the gap, again, you can do F, and that'll give you a flat surface. And here, it's not ideal, and this is why you want to be careful when you're manipulating your mesh, because you don't want to accidentally make big holes in it, because you can see like it just fills a really straight surface, and so it loses the curvature of the model. So you really need, if you ever make your own geometry, you really need to make sure that it's actually realistic compared to the CT scan, that you're not like over smoothing areas, that you're not missing some geometry, especially for finite element modeling, but in general, like just make sure that you're not actually changing the structure of the model. And then, so now we have this really big surface, right? But we want there to be triangles, at least for finite element modeling. We want there, some people model them as quads, but in this case, we want there to be, the faces to be triangular, right? Instead of this big polygon. So one really easy way to do that is we select this as a face. So we go into face mode, select it, and then face, triangulate faces, or you can do Control T. So this makes triangles, but you can see this is like, these triangles are not at all the size of the triangles in the rest of the mesh. And this is especially important for finite element modeling because you want the, like all of the finite elements in your volumetric mesh later on, you want them to be like similarly sized and not just these massive spiky ones here. So sometimes you'll have to make your own geometry. So, and again, you wouldn't usually have these massive holes that you need to stitch up, but I just want to show you like as an example of how you would make your own geometry or make your own faces. You're still using the geometry of the model to inform what it should look like. So there's something called the knife tool that's down here. So it's like a box with a little cut through it. And that basically lets you draw vertices, and then you draw it and then you press enter and there's a face. There's a face. It's useful to have edge snapping on again. There's a face. We can use our move tool just as we did for the object on if we go back into face mode to move the, and this is when we turn off object snapping because otherwise it'll try to connect to the nearest vertex, and then you can also move these around. So I'm just going to quickly do a few more so I can show you another tool. Again, these are too big. This is not what I would do, but just as an example. Say we had these, and these are like really big compared to the other ones. Another thing you can do is you can locally smooth the vertices. So this will make them more evenly spaced, and also at the side, if they're like, there's like a kind of sharp edge, it helps with that. So you can select your vertices, go to vertex, smooth vertices, and then you can have the amount of smoothing here. So you can see the higher I make it, the more evenly spaced they are. And probably I should have also selected this one. vertex smooth, then they're a lot smoother. So this is another way you can, if you have some areas of your mesh, just because of how your CT scan is, that have like really big triangles for some reason, like here, you can see that's what happened over here. That's a way to, you can manually move the vertices, you can delete areas and redraw them, or you can use the smoothing. Also for the knife tool, you can also go through existing ones. So for example, if I want to connect a vertex to another vertex, but there's an edge in between, it'll automatic, like you can click on the edge to make another vertex there and then go to your next one. Like you can change kind of the line that you're drawing. Does anyone have any questions? I see there's some in the chat. Spherical harmonics. I don't know what spherical harmonics is.
If I may, it's a mathematical method to model your 3D surfaces in mathematical space, so you can do statistical analysis on sameness, shapes changes, if you want to compare some structures, for example. And I was wondering, because the problem is I understand the method is projected on a spherical on a sphere, and with this you have a problem if you have a concave parts of your or two concave parts of your surface. And since I work with invertebrates, so with spiders, you have more of a concave or easier concave surface than with vertebrates. With bones, they don't have that as much, as I would say. And I was wondering, I'm still trying to find a way to manipulate my surfaces that I trust the surface still, but I have closed this like with a rubber thingy or whatever, this surface. It was just like, if you know techniques like that, but yeah, again, special questions.
Sorry. Yeah, sorry. Yeah, I don't. All right, so I'm just gonna undo a bunch of this because does anyone have any questions about all of those steps? No? Okay. As you can see, the undo is working pretty well. Let me check what else I wanted to talk about. Okay, so another thing that might happen is that you might have floating elements. So there might be like I don't have one, like an actual example here, but just conceptually, say there's this vertex that's connected to all these other vertices by edges and faces. But for example, at that same coordinate in space, maybe there's another vertex, but it's not actually part of the mesh. It's just like occupying the same position. So that's called loose geometry. And I think there's just like a mesh cleanup, delete loose. So you can just do that and get rid of it because that might cause issues with your mesh as well. You could also have the issue that your object has like floating bits. So they're not necessarily loose because they're not just a vertex in space, but they're not connected to the main geometry. So this might happen if you're segmenting a CT scan and you accidentally like selected a few pixels that are not part of the object, or maybe it's a fossil, or I mean even extant scans. Maybe there was just something that you thresholded or segmented that you don't actually want to be part of your model. So I think there might be an example of this internally here. Yeah, so you can see here in this model, there's like a ton of messy stuff going on inside. Oh, and actually this is a good time to also show you, sometimes you get to a point where you like want to zoom in more or see something from like say I want to see this floating bit right now, but I'm like trying to view it, but then the pivot point of the camera is like not set on it, so it's really annoying to see. The way you deal with that is you go to view. So you can have, if you select it, you go to view, frame selected, and then it zooms in on it and you can pivot around it, which is really useful. So here we have this really annoying little piece. And if we're 3D printing or doing finite element analysis, we don't want that in there. It's not useful at all. So probably what happened here is that this scan had like some trabecular architecture inside, but I mean, unless you're modeling the trabeculae for FEA, like usually you will want just like the surface mesh, and then you convert it into a volume mesh in a different program. And then it just fills in that surface. So this would confuse that program. So to get rid of this, here we have one selected. You can do select linked, which is Control L, and then it selects everything that's linked to that. And then you can just delete it. But another way to do this, so say we have loads of little floating things, and we only want to keep our main model, is that instead we select a face on the main model, then Control L, so select linked again, and then Control I, which inverts the selection. So whatever is part of that object, it doesn't count other objects in the scene. So if I imported another OBJ or STL, like another bone, it won't count that, because in edit mode, it's only always the one object. But in that object, you can have like separate pieces, right? Like that little floating piece I showed. And when you do Control I, or you can just go select, if you forget these shortcuts, select invert. So basically before, wait, sorry, maybe I forgot to tell, did I say select? Maybe I didn't. Anyway, I don't remember if I said this step, but first, if you selected that outer bit, you do select linked again. I think I did, but anyway, make sure to select linked. So everything that's connected to this piece is selected. And then, yeah, you do Control I, and that selects everything else that's in that object, but that's not connected. So here you see we're actually picking up a lot more of these little floating bits. So that's really the quickest way to go about that. You can also see, let me unhide it. And here, I'm just gonna select some more and hide this. There's like, because of the scan and because of the trabeculae, there's this whole middle layer that has this really messy geometry. And it's because of also the break in the bone. Yeah, this is definitely just the break in the bone. So you see it's going in like that. And maybe for your print or your finite element model, you want the fossil exactly as is, which is broken. And then that's fine, because as long as it's not super messy in there, I mean, it is a bit messy, but as long as you do all the mesh cleaning checks, it should be fine. Like it would just model your volume, or when you print it, it would just be as it is. But if it's a break and you're interested in what the fossil would have been like before it was broken, then you can fix all these areas. And again, that's where that kind of making your own geometry comes in handy, because you can then essentially make your own faces. So I think we're almost at the end of the session, because this one is only 1 hour, but usually they're 2 hours. But I didn't realize that the US changed time zones before us, so it's not quite as late as I thought it would be for me. So I'm happy to keep going, because I have a few more things to go through. But if other people need to leave, that's totally fine, and they can just watch the recording later.
I totally forgot about that.
Yeah, I almost was, I realized like an hour before this, because I was like, oh, I have so much time. And then I was like, it just crossed my mind. It's like, oh my God, I almost missed it. So yeah, this is where like making your own geometry or filling in the gaps essentially comes really in handy. Another thing you can do, I'm just gonna do like a really rough way, is that if you, so essentially you would go in, delete some of these internal, like the ones that are inside the break, these faces, and then you would fill in these gaps. Now, if you actually have two parts that both have an open hole and you just want to like fill the gap between those holes, so for example, I'm just going to do this really sloppily, but if you had something like a bunch of stuff. So there's like a really useful tool. Basically, if you have two open loops, what you can do, I have some messy stuff, so I'm going to, again, You don't have to do this, just bear with me so I can show you these things. I'm just cleaning up some of the messy bits so that I can. Also for the whole, like if you're doing the Control L for the selecting linked and inverting, sometimes you'll get rid of the faces, but sometimes there'll be still the edges and vertices. So in general, it's best to do it in vertex mode because that should get rid of everything. But I just did it in face mode first, which is why I now need to do it to get rid of all of these edges. Okay, so let's hope this is clean enough. There's some annoying edges on the side. This is why it's good to work in vertex mode in general, because then you don't have these annoying things. Oh, what a mess. Yeah, when you're doing the select link thing, definitely work in vertex mode initially, because otherwise you have these floating vertices. Okay, now I can finally show you what I meant to show you. Just make sure it's good. Okay, well, let's see if it works. So you can be now you can be in edge mode or in vertex mode. So now I'm selecting these edge loops again. And again, you can, it's the Alt double click, but you could also, if you forget this, like a lot of these shortcuts I just use because they're quicker, but you can find them by going to whatever features you want. So for example, when we did the triangulating the faces, you always have that under face. This one is edge, should be bridge edge loops. So, sorry, first we were selecting the edges. I don't remember where that is. Just, sorry, just use the shortcut for now. And all right, the geometry is too complete. No, there's a little edge. Okay. So sometimes it can't select the edge loops very well if there's some difficult geometry, but then I got rid of that annoying little face. So I basically am selecting the edge loops. It's not automatically doing it. Sorry, this takes so long, but it's just something that I hadn't planned on showing you, but I realize it's really useful actually.
Is that one straight point problem?
Huh?
There's one straight point. Is that a problem up on the top?
This one?
Yeah.
Yeah, that's actually like the center of mass. But it looks like a selected point. It totally looks like a selected point. But yes, that would also be a problem. I think there's a way you can turn it off. Let's see. Something about, let's see, I think it's, yeah, it's the origin of the object. So if you want to turn it off, you go into options and then origin. But yeah, thank you for noticing that. But yeah, in this case, it's not a vertex, but it looks like a selected vertex. Anyway, this whole thing took longer because if they were like more clean cuts, it would have been better. So if you do have messy surfaces and they're generally two open loops that you want to join, might be worth cleaning them first so then it's easier to select. And then you can go to edge, bridge edge loops, and then it connects them automatically, which is super useful. Here you can see it's a huge mess because I just made the distance really big just because it was easier that way to show. And now your triangles are really messy. But in general, this is something you can really easily use to connect two open loops. And I mean, if I'd done this if I wanted to fix the breaks in this object, I would really, go in and do it, select the edges very precisely and make sure they line up nicely. Okay, some people are leaving. Thank you so much for coming. And if you ever have any questions, feel free to just email me. I'm happy to answer any Blender questions. So right now is actually a good time to go over remeshing, because maybe you did have to fill a huge gap and now you have a mesh like this with massive triangles here and tons of really small triangles in the rest of the mesh. And you could go in and manually fix all of this. If you smoothed it, it'd be really difficult because these are really big. So you'd have to have like a massive smoothing factor, and then it would mess up all of your other triangles. So this is somewhere where actually a remeshing operation might be useful. And you can always think in your model, maybe you don't need to do all the mesh cleaning. Maybe you can just do a remeshing operation, but I wanted to show you kind of the logistics of doing it all manually first, because then you can see what's going on. And that way you have complete control over how the morphology changes. Whereas if you remesh, and also if you decimate, so if you downsample meshes, there's always the possibility of things getting smoothed over. So I don't know, maybe these little, probably there were like little frame in there, but maybe you have actual structures. So for example, in the jaws, we have like the mandibular, like where the Meckel's cartilage is, there's like a little canal, and we want to keep that in our models. So you always need to kind of decide which internal features or which small foramen or whatever do I want to keep. And if you decide you want to keep them, then you need to make sure that if you're doing remeshing or decimating, compare it to your initial mesh and make sure they didn't like completely get smoothed over. Or you could even get this, I mean, if you have a jaw with a bunch of teeth and you smooth it like crazy, the teeth are going to get way less sharp and kind of get like smoothed over. So always use this with like a grain of, like a good amount of caution, and always compare it to your initial model and see, am I okay with this being smoothed over? In other cases, maybe I do want this to be smoothed over automatically, because then I don't need to worry about fixing this little break. So, so the way to do this is there are two different options. There's the automatic, like it's an automatic remesher. So basically once you do this remesh operation, your initial mesh is gone. So you can undo it, but it's like it completely replaces the original morphology. So you could make a backup, like you copy up here in the like object hierarchy, you can make a copy. You can copy and paste. You can also do Shift D, which is duplicate. So Shift D, and then press Enter right away. If you do Shift D and then move your cursor, it already like moves the copy, which you probably don't want, unless you want to just like move it somewhere as like a reference to the side. So yeah, Shift D for duplicating. Now my undo isn't working, so clearly there is an issue. It's weird because a few times the Control Z won't work for undoing, but the undo button will still work. And I haven't figured out when that happens, and it's very rare, but it just happened. But anyway, that's what the remeshing does. So here we would do F3, which is a very useful tool because F3 basically just brings up a search bar. And then you can search any tool in Blender, because Blender has a ton of tools and they're not necessarily in the tool menu. So you can always go, the Blender documentation is really good. You can just Google it, but sometimes, or usually it's way easier to just search for it. So we go to voxel remesh and then click it. And then it took a long time and it looks all weird and it didn't work well at all. So this is the problem with this remesh option, is that it like automatically remeshes it. And sometimes it works really well, but it's kind of the default settings. So if you want more control over it, and if you also don't want your initial mesh to be destroyed, instead we can do something that's called a modifier. So this was like really confusing for me to wrap my head around when I first used Blender, because I was like, why can't I just use the tool and be done with it? But they're actually super useful. So modifiers in general, there are a bunch of different ones. They're really useful because they don't change your object yet until you apply them. So for example, if you mirrored something and then you moved it, if you mirrored something and it wasn't just a modifier, then if you moved it to one side actually, let me just show you this because I think it's way easier to see. And then you have to put the origin of the cursor. Okay. Let's find a good example. So you can, why is this not working? This is very weird because usually what you should be able to do, since it's a modifier that I didn't apply yet, if I like move one side of the mirror, it should actually like, if I move one of them away from the center, it should actually be mirrored. So both of them should go farther away from the center instead of like moving along with each other. I haven't used this in a while, so I'm not sure why it's not working like this. Must be like automatically applying it or something. Well, this is like not at all proving my point, but okay. Sorry, ignore that. Usually I'm going to go back to this, and if anyone actually wants to use this, let me know and I'll figure out why it's not working. But usually what the modifier should be doing is like, it shouldn't be making it into one object that's now a solid object that I'm moving around, but it should still keep track of, we still have the mirror, but if I move basically if I applied, what should be happening is if I applied the mirror, if I didn't apply the mirror, but I put the mirror modifier on, and then I moved my object, the result should be the same as if I had moved my object first and then applied the mirror, if that makes sense. So it's basically like it will, if I move one side in the x-axis by a set amount, the other side should move in the negative x-axis by a set amount instead of like keeping their distance constant and moving around. And I'm really not sure why. Maybe it's changed in the newer version of Blender, but I will look into this.
There was somebody telling you that you're in object mode and not in edit mode, and that might be the problem.
Yeah, so in edit mode, it's the original mesh, but yeah, in edit mode, it's basically like what it would look like without the modifier at all applied. So it's really useful if you, so in edit mode, you could change the mesh, and then in object mode, that should be reflected in the mirror. But before, like I have had it where even in object mode, you can move the object around and it should be mirrored nicely and not like this. So I don't know. I'm not sure what's happening here. So I'm gonna get rid of this, but that was a bad example, I guess. I'm not sure because yeah, before it was working fine, but we'll just go to but just think about like, regardless, like conceptually, it still applies that like the modifier is not changing the geometry or shouldn't be changing the geometry yet until you apply it, which is really useful for the remeshing because it basically means we can see what the remeshing is like, but then if we don't like it, we can just undo it, or we can like make all these adjustments and see it update like in real time. And then when we have something that we're happy with, then we apply it. So for example, we go to remesh and then voxel, and you can see it's just gotten rid of absolutely everything. So our voxel size is way too big. And then we can go, and sometimes it freezes a lot on this. So this is the downside to the remesher, is that if you like each on the slider, each kind of point is like exponentially different. So then you can go from like something with a really big voxel size and it being really quick to compute to being super slow, or right now my computer is freezing, which is really frustrating. Any questions why wait for this to load. No, okay. Thanks, Chris.
Thanks for showing
I'm
us
like
the
chilling.
reality of working with Blender, Eva.
Yeah. All of the issues. And yeah, that's so weird about the mirror modifier, because I remember it took me so long to realize like what it was doing, and why it wasn't like applying it right away. And then now it's like doing the exact opposite. So I don't know. I'm just going to start Blender again.
We do have one question, Ava, while you're loading again, from Ian McGill. When you're patching holes in the mesh, is it necessary to have tries similar in size to the rest of the mesh, or is it sufficient to just approximate the shape?
That totally depends on what you're doing. For 3D printing, if it looks visually nice to you, go for it. For finite element analysis, I don't know if there's like a strict rule of exactly how similar they should be, but in general, I would say aim as similar as possible. But also when I'm doing this, I'm not like going in and measuring the area of the faces and having it be super exact. But and like for my teeth, because of the really thin layers, like I needed there to be some smaller triangles to kind of account for like this very thin structure, whereas the rest of the mandible, if I'd made everything that small face size, then it would have been like impossible to compute. So at some point you also need to see, okay, what trade-offs are you willing to make computationally? But there I still tried to make like the rest of the mesh as similar as possible within like the constraints of actually being able to load anything. So I think in general, try to make sure like what I just showed would be terrible, because the triangles are really, like there's several multiples bigger than some of the triangles than the other ones. But also I don't think you need to go in and like measure them. So I think if visually it looks like the vertices are evenly distributed, that's pretty good, I would say. And then you can also, I mean, if you wanted to, you could do like the way to really test things for finite element analysis is you can do convergence studies, and you can kind of see, okay, if I change this, or if I like oversimplify only this area and kind of smooth it or have bigger triangles, does it actually affect my output? But then you need like kind of a golden standard model to do those tests to see if it does make a difference. But in general, for finite element modeling, I would say make them as similar as possible without going in and measuring every single one of them. For 3D printing, it's really up to you what you want it to look like. For some range of motion analysis stuff, like some of the automatic osteological, like bone intersection approaches, you need clean meshes, but I don't think the triangle size matters that much, but you want to find enough resolution that, again, the geometry is accurate enough. Okay, let me try this remeshing thing again.
Eva, I just have a question while you're doing that, if I can.
Yeah, sure.
So I was wondering if it's got an automatic like split edge function. So if you selected all those really long triangles, and does it have an automatic like split edge? So it just adds an extra vertice in the middle of a long edge and then splits it into another triangle. And then you could use that operation over and over again on the same long triangles.
I haven't actually tried that, but that's a super good point, because that would be really useful. Let me see.
That's something that I've used in a Viso before. So I was wondering if this has it as well.
Okay, yeah, let me see if there's, I mean, I'll just try it on this. Split edge. I don't see any, but I'll look into that because I feel like that would be super useful. Subdivide, maybe. No, that didn't do anything. I'll look into that. It seems like it should, I mean, it has so many features, it seems to me like it should be capable of that, but yeah, I'll look into that. Okay, let's go, yeah, because I guess that would be way quicker than, yeah, if you were like manually going in with a knife tool. The nice thing with the knife tool is if you have like, let's have a really quick example of this. So say you have something like this. So you have this like messy junction here, and there's like a shape that's not a triangle. When you tell it to triangulate this, this quad face, it'll automatically make sure that it aligns with that, with this edge here. Huh?
Would you mind sharing your screen again? Because we couldn't see what
shoot,
you were
sorry.
showing us.
Thank you for saying that. Yeah, that's important. Okay, so can everyone see this? Cool. So say we have this face here that needs to be triangulated, and I just like, for example, drew this edge here. It's nice because when you do triangulate this one, it'll automatically connect to that vertex here. So here you can see that it's connecting there. So that also, if you do have to fill in geometry, that makes it a lot quicker because you can just leave some things as squares and then just like draw the edges up to where you would want the other triangles to be, and then it'll just fill it in automatically. Okay, thanks everyone who's leaving. All right, remeshing, yes. We can see if it works again. If it freezes again, I'll use it as an opportunity to show you how you need to be in object mode for this, to show you how to decimate, because that's also important. Okay, that's odd. It really didn't like those big triangles because now you can see the remesher worked immediately and didn't like, before it was like getting rid of all of the geometry because it was really confused, whereas now it's doing a nice job. In general, there are like different remeshing options. There's block, smooth, sharp, and voxel. And voxel is like a pretty new addition, I think. And in general, it works really nicely. I guess before, because the triangle sizes were so different, it was having issues calculating it, but you can see it like, it did turn it into a quad mesh, but then you can really easily go back. You can see did this. We still have some of these weird things here, but then we can go in the modifier, we can change the voxel size, and we can also change the adaptivity, which is basically how it's deciding how to allocate those different faces. So then you can do smooth shape. Don't mess with that. This is quite useful. And again, just make sure that like check it with your normal model, but sometimes this can be really useful for getting a nicer mesh. Then if you're happy with it, you click apply, and then the modifier goes away. And then this is now your actual mesh. There's no previous mesh left, but it's nice because you can apply it like after you do a bunch of tests and see what you want it to look like. Similarly, there are various modifiers. There's a decimate, which is really useful because you can make it smaller. So we can say, okay, we want half the number of faces or something, and play around with that as well. That one you can directly make it triangulate, which is quite nice. Okay, I think I'll go through one last thing once I go back to my mesh. Okay. So the last thing that I want to go through is really sharp triangles. So you can see this mesh is terrible for that. There are like tons of really sharp, spiky triangles. What I've been taught for finite element analysis is to go to aim for angles in the triangles that are greater than 20 degrees or less than 150 degrees. I'm not sure if other people have different opinions on that. The code I wrote is for that specifically, but you can go into the code and just change your angles if you want to set a different range of angles. So to do that, you want to go to that Blender repository that I shared, and then you copy my script, which is the select angles Python script. So does everyone have that script? Yeah, okay. And then you want to be in object mode for this to work. And Blender works with Python. So Python is the language that you use if you want to code something in Blender. Blender is super great because it's used so widely for graphic modeling and for animation and things like that, that there are tons of resources out there. So there are like lots of support forums where someone's like, I'm trying to, I don't know, select all my vertices and renumber and like reassign the indices of them, or I want to export all the coordinates of my vertices or whatever. Like chances are that someone has asked that question, or you can ask that question. And there's like a really big community out there versus, again, I feel like some of these commercial programs that we're just using for research, it's like a really small user group, which is probably why they're so expensive. And then it's really hard to get some sort of feedback for it. There are also loads of really good YouTube videos for Blender. But basically, if you want to learn to code Python for Blender, I just started Googling things. I had like a rough idea of what I wanted to do. And then you figure out, okay, what scripts do I need to kind of combine together? And then you essentially just test it out. And so you go into this, there are different modes up here. So there's also an animation mode if you want to animate, rendering for if you want to make some nice figures, and then there's scripting. And then this is called the Python console. So this is down here where that like red bar is where you type in your code. And then you want to make sure you're in object mode and not in edit mode. I think you want to select your object. Yeah, select your object and then just paste the code. And then press enter twice to make sure that it's actually running. And then go into edit mode. And then go back into edit mode, go back into your layout. You can see all the super sharp triangles are selected. And this would be like such a mess to clean, which is why you'd probably use like some smoothing or just remeshing in the case of this mesh, because it has all of these really sharp triangles. Never really had like I just pulled this from a random folder that I had, but with my finite element models, I've never quite had this extreme of an issue. So I usually would just do it manually if it's like a few issues, because then you can just, you know, take your vertex, move it around, make sure that it's more evenly spaced. Or again, what I was saying earlier is doing that snapping tool. So you don't necessarily want to just move them all apart, because then suddenly you get like smaller triangles that are half the size of what they were before. So things that are really close together here, you just snap them together and get rid of all of them. So that's pretty quick. So that's a good way to get rid of those. And again, make sure in your options, the auto merge is on, or you can also do, I think you can do mesh, clean up, merge by distance. You just need to do this at, like, you don't need to do it before you make all your adjustments, but if you do either have the option on while you're doing it or afterwards, do the mesh, clean up, merge by distance. That basically just makes sure that you don't have like two distinct edges that are just occupying the same space, but that in the mesh, it's actually just turns into one. Another thing you can do if you have like, if you're cleaning a bunch of areas, so say I had all of my sharp things selected, you can make vertex groups, where were the vertex groups? Yeah, so under the this green upside down triangle, there's vertex groups, and you can make, this basically just has Blender keep track of all the selected vertices. Like you can assign them, and then when you unselect them, you can always go back to that initial thing. So for example, here I'm going to call my group sharp triangles. And again, if this mesh is so messy, it would take ages to fix by hand. But in my experience, like with the meshes that I've used, usually you'll have like less issues, or yeah, or just you need to figure out a way to remesh it nicely. But say you have like a manageable number. So say if you have like 20 or 30 that you need to fix, then doing it by hand is super doable. And so I would put it in the vertex group sharp triangles, have the select and you assign it. And then you can see if I click over here, I can always select them again. And that's really useful because say I actually want to go into fixing them. So when I fix them, I'll be here, I'll be manipulating things. I don't know, say I fixed it by doing this or whatever. Once I go back, I don't want to have to rerun the code every time, right? So it's really useful to be able to have this vertex group. You can also use these for various other things. If you just want to keep track of a certain group of vertices, then you select them again, and there they are. And if you had something that you just fixed, so you know, okay, actually this one is fine now, you can always select it and then do remove from the group. So then actually that one shouldn't show up anymore, right? Because you don't want to like keep it in the vertex group, because then when you'll check it again, you will always be looking back at the ones you've already done. Or you can just fix a few in different areas, rerun the code, redo the vertex group. So like you would select everything, remove everything, redo it after a while to then only see the ones that are left, or again, remove them as you go, so that you can keep track of which ones you fixed and which ones you haven't. But of course, you'll also be able to see which ones are sharp and which ones aren't. So I think, did that work for everyone? Yeah. Cool. And yeah, in the code, it's pretty clear, like there's just like, if angle is less than 20 degrees or greater than 150, just like, if you want to change that, just change those numbers and that should work fine. I think those are the main things I wanted to go through. There is one last thing that is kind of relevant, really good to know in general. This happened to me the other day. If you're exporting your models, you can export as OBJ or STL. And I'm not sure if I changed this at some point or if this was like the default, but I ended up sending a collaborator to, or someone who was like running some tool on my models, 2 meshes, and I didn't know if they wanted OBJ or STL. So I sent both to him and they ended up being like different orientations in space. And it's because when you export, you have to tell it, first of all, there's like batch mode, or you can do object if you just want to select only one object in your scene. So you can do like selection only. And then the scale. So there it's also good to set your scales, but usually even if the model has scale like 0.5, whatever it is in your scene is usually the size that it exports as. But if you want to be like super safe, just always make sure to apply the transforms before. But yeah, here's where the orientation got messed up. So here's like Y forward, Z up. So we can see in our scene here, these are the global axes. We have Z up, that makes sense. So that'll export exactly as our scene is. But for some reason, my OBJ settings were like X up or something. So then it ended up like having the right, because X is over here. So it would just like flip the on its side. So just check that. But it's also useful because it can, if you decide, actually, I want to have my, sometimes you have a model in a certain orientation in the scene just because it's easiest to view that way, but then maybe in a different program, because I don't know, say you're doing, for example, I'm doing draw joints, and generally with like rotation orders, I mean, right now I'm just doing like a really simple rotation joint of like opening and closing the jaw. But just from my background in joint range of motion, like usually you want to assign the axis of the most movement to like your first axis of rotation. So there, basically what I'm trying to say is like in different programs, you might have might want something else to be the Z axis. So for example, in my model in Blender, Z was up, but in my model for the jaw, the way I wrote the code, just because I like thought of it this way, I put the Z axis as the actual like rotation, opening and closing of the jaw. So that's really nice because you can easily change these things. Just think about like, how is the global space in Blender and how do I want it to be? So that can also be really useful to change these things, because then you don't have to like in your other program, then like rotate the model and apply the rotations and whatnot. So just something to keep in mind. Also here you can see there's like an apply modifiers things. So if you didn't apply them, but you don't feel like clicking apply on every single one, you can just do apply modifiers, and then your geometry will be like what it actually looks like in object mode, versus even if you didn't apply them yet, in object mode it might look one way, in edit mode it'll look like the way it looks originally. So yeah, just some things to be aware of. And then one last thing where this I mean, I already mentioned it and Sandy mentioned it, this mini conference that we're having is on Wednesday, and I put the link in the chat, and we're also trying to form like a bigger community. So we have a website, and put the website link too, and a GitHub organization, and we're basically looking for contributions of any 3D modeling approaches that tie into finite element analysis. So it can be analysis steps. We're especially interested in like open source freeware programs, but also any other programs. But it can also be like creating models from CT. So if any of you have any workflows that you've used for other work, even if you don't do finite element analysis, we'd be super happy to have you contribute. And basically how it works is you would upload it on your GitHub. Then we make you an organization member. So you basically fork it, which is basically like you give us a copy of your repository with your workflow or code or whatever. It shows up on our or GitHub organization, and then it also just automatically shows up on our website. So I can kind of show you what it looks like. Change the screen. And then we also have a Slack for this. So if any of you are interested in, can you see this? Can you see the website?
I can see the website. I see the Blender workshop funky morph doc, but then I see some black squares.
Oh, weird. Okay, let me try it again. Does it work now?
Oh yeah, I see the website. Yeah.
Okay, cool. Yeah, so essentially like we have this website too that's just like this basically explains what we're doing, and then in the workflow, so if you contributed a workflow, we have it set up so that automatically as soon as you put it on our organization, it'll show up here, and then it has like these little stats and who the contributor is and when it was updated and whatever description you want. So it basically just gives more visibility to your workflow, and then we're also hoping to reach more people. So if you were thinking of learning finite element analysis, we're hoping this will be like a really useful resource for people to get into it, because in my experience, it depends so much on like what programs does your department have? Do you have connections who know the modeling workflow? And there's just like so many steps that, I mean, you know, like the fixing sharp angles thing and stuff like that, you would maybe never know about if you were just trying to teach it to yourself. So we're trying to get more resources out there, make it more accessible for people. We have a Slack as well. There's a Slack link on the website. So I'll put the website in the chat as well. And yeah, we would love like any more contributions, because right now we only have a few, but we are definitely getting more people interested in it. So yeah, I think that's everything. Does anyone have any other questions? No. Okay. Also, if you ever have any questions about Blender in general, I'm super happy to like just email me. I can put my email in the chat too. Yeah, super happy to share things. Or if you find a better way of doing things, also let me know, because I would love to, yeah, have feedback. And if you find a more efficient way of doing things, I would love to update my my Blender guide as well. So yeah.
That was awesome. I'm super psyched for your seminar series. I just signed up today.
Yeah, I saw.
And, but yeah, if you can unmute, just give a round of applause for Eva. That was amazing. Thank you so much. I learned a ton. And it's really helpful to have everything on GitHub too, because we can submit issues to your repo and ask questions there. And if you like this tutorial, please do star Eva's repo on GitHub. It can be really helpful to kind of gain attraction and show, appreciation for the work that she's been doing. All right. Well, that was really fun. So next month we do have another session already picked out. I put a link in the bottom of the chat box. We will be having Dr. Arthur Porto show us, now that we have a 3D model, how do we start with the analysis, which is landmarking. And he's going to be showing us some machine learning techniques that will automate the landmarking process. So you don't have to necessarily pick landmarks one by one. There is virtue in doing that, but this is just another option that you can pursue. But thank you so much, Eva. That was amazing. Thank you so much for your time and for walking us through this and kind of welcoming us into the FEA open source community.
Yeah, thank you so much for having me. That was super fun.
I've never done let you get to bed.
Awesome. I was just gonna say I've never done like a workshop before, so it was like pretty fun to do it, except when the mirroring wasn't working and I was just like, oh no, why is this like doing the opposite of what I literally just said?
It's so helpful though to see
It's
that other people
errors
struggle in the way that I do with mysterious issues. So no, I think it's great. Like, people like, yeah, we're not putting out an artificial like this is so simple and it works 100% of the time. Like sometimes they're weird things. So yeah, thank you for allowing us to experience as you were going through it.
Yeah.
Felix, go ahead.
Do you use or what program do you use for the finite element analysis in the end? So do you have open source already? Is there something where you can use it, or is it just like always? I used in my diploma thesis years ago MarkMentad, which was okay, but a pain for the models to create. I haven't tried ANSYS, but because I switched in my field or in my studies, but yeah.
Yeah, so my collaborator in Birmingham, Stefan Lautenschlager, he uses Hypermesh and Abacus, and I kind of like, he does all his mesh cleaning in Hypermesh, and I hate the interface, and it's also like really expensive. So that's where I like changed it to Blender, but then I was still using Abacus for a small project for the analysis. But what I've been learning the last year is a program called ArtiSynth. So they're kind of, because I knew from the beginning, like because our lab hadn't yet like purchased a license, I was like working with my collaborator to do the Abacus stuff because he has a license. But then I was like, really, do we need to spend I mean, we have these really fancy segmentation softwares, but like I'm about to learn my own, like I need to basically start at the beginning anyway. So I mean, I had some like experience help with my collaborator with Abacus, but I was like, really now is the time for me to like try to learn a new program that's free. And I was thinking about ArtiSynth and tried to, and it's all code based. So it's like all Java based. Couldn't do anything. Talked to a postdoc that was using it and at the same university. And he was kind of like, he had like an engineering background. And he's like, well, if you can't code, if you can't code very much, like it's really a steep learning curve. I don't know if it's really ideal for what you're doing. He recommended something called FEBio, but then I couldn't get FEBio to, I don't know, it just wasn't that intuitive because like just muscle forces and things, like they just seemed a bit more intuitive in ArtiSynth. And then I went to a conference and the ArtiSynth software engineer was there and another PhD student who was using it. And they helped me like set up, they actually were like, oh, to make the models, you actually need to like install, well, you don't need to, but you can like install something called Eclipse, which is basically like where you write all your Java code. And then you can like also see the code from all the demos. And they're really great and helped me set it up. And so in the last year, I was like learning, like I've been like, I made some models that are basically just tests, like not my actual geometries, but, you know, like simplified models, like basically shrink wrap the skull and the jaw and just tried that. And that's really great because it's really good documentation. It's free. It does multi-body dynamics and it does multi-body dynamics combined with FEA. So you can have like map on the muscles and then have part of your model be a finite element mesh. Of course, you can't have it be like super, super, super detailed because then it would just like take forever and freeze. But you can also do static analyses, which I've tried. So I can basically connect the jaw and the skull with some muscles, apply the muscle forces, model the jaw as a finite element mesh. It's a steep learning curve, but once you learn it, it's just way better, I think, than stuff like hypermesh or something. Because there, if you apply the muscle forces, you have to like pick the point, like, okay, the muscle is attaching here. Then you pick, okay, the force vector, like the direction is here. But by the time you like get to that screen, you can't even see where like your initial point was.
Yes.
And then, yeah, it's just like, and then if you don't like it, then you just have to delete it and redo it again. Or you'll be like, wait, did I just do like the point for the left or the right side? It's just a pain.
One
and
of the
already
problems why I never published my diploma thesis, because I knew I did something wrong with the scaling of the models. I did crab or hermit crab claws was and modeled them and tried to get something like if there's some in the form and shape, if there's something of information. And yeah, the modeling was such a big pain that I did it and I did it again and I did it on I calculated on the cluster server from the university but the problem was the person who installed the software in the beginning, she was pensioned afterwards, and and then you can forget it at some time that you don't trust your work anymore. The first run was good, but then afterwards, yeah. So that's why I ask, it's like if there's some nicer software for the modeling.
Yeah, it's a steep learning curve, but it's definitely really nice.
Heavy.
Yeah, I mean, you could, for that case, you can go back in and say, you can just change the coordinates of one muscle, or for your scaling issue, you could just say scale the everything, not just the model, but like scale the muscle force, scale everything by this factor. And you always have your code. And so you can just make little adjustments. And there's a user interface too. So you can physically move like a muscle attachment, just query the coordinates and then put it back into your code. So and actually the day after the seminar series, we have a workshop for ArtiSynth, but it's full because we had to cap it because like we want it to be interactive enough. But we are making a recording of all of it because the software engineer said he was happy with that. So if any of you are interested, email me. I can send you the recording afterwards. Yeah, it should be super interactive because I was basically like, we don't know, like usually most of us don't know Java, like can you please go from the very basics? Because like when I started too, I was just always asking them, like I just didn't understand like the object-oriented programming and just how anything was working. So I think we'll do like a very simple, like here's a point-to-point muscle, here's how to set up a joint, maybe here's how to set up a finite element mesh. So that should be like a really good tool.
During my PhD, I worked with physicists and I envied them so heavily for their academic culture. So they learn programming and coding during the whole studies.
Yeah,
it's hard at the beginning. They get really punched heavily in the first semesters, but then they use it throughout the whole studies. And in the end, everybody of them can code at least somehow better than every normal biologist if they are not like having this as a hobby normally. And so with that, I think sometimes we're missing out in our studies that we just give them a little bit more of the what you need nowadays to use all that, what we need to use. It's crazy. It's getting bigger and bigger, and
yeah, definitely.
Yeah, I totally agree. It's almost uncommon now to not include coding into your research. Totally agree with that.
Still trying to avoid it. But big thanks again for the organization, even though it was a little bit bumpy. But I know how hard it is to do things like that if you try to organize a conference, a small one. Even that is like...
Yeah, thank you all again who are still here and who will watch this later for tuning in. But yeah, as Sandy mentioned, our next session will be April 12th with Arthur Porto. So we'll be sending out information on all of that in a registration form for that as well. Yeah, thank you again, Eva, so much.
Yeah, thank you so much for organizing this. It's super fun.
Absolutely. Thanks, everyone, and see you again in a month.
See you.
Bye.